Hello my dear students, welcome back to my channel. Today I am going to start multiple choice questions of chapter 1 electric charges and fields. In the previous video, I already discussed about case study based questions and assertion reasoning type MCQs. And today I am going to discuss third type of MCQs, that is multiple choice questions. In this type of questions, 4 options are given. You have to choose the correct one, right? So let us start with question number 1. Question is, a glass rod acquires charge by rubbing it with silk cloth. Suppose this is glass rod and it is rubbed with silk cloth, right? So after rubbing, the charge on the glass rod is due to, due to rubbing, electrons transfer from one body to another body, right now? So this rubbing process is called what? One becomes positively charged body, another becomes negatively charged due to transfer of electrons from one body to another body. Why this transfer of electron takes place? It is due to friction, conduction, induction, radiation. Which option is correct? Yes. Pause the video and try to solve it. Yes. Option number A is correct. The charge on the glass rod is due to friction because electrons are transferred on rubbing, right? Due to this friction process. Okay, hope you understood. Next, question number 2. Next question is question number 2. Charge on a body is integral multiple of plus minus E. It implies the law of, charge on any body is always an integral multiple of this smallest value of charge, that is charge of electron, fundamental charge. It means Q equal to Ne. It implies law of, first option, law of conservation of charge, second one is conservation of mass, third one is conservation of energy, and fourth one is quantization of charge. Which option is correct? It is according to, yes, try to solve it. A or D, conservation of charge or quantization of charge? Yes, option number D is correct. According to quantization of charge, charge on a body is integral multiple of plus minus E, right? So, option number D is correct, right? Next, question number 3. Question number 3 is, when 10 to the power 19 electrons are removed from a neutral plate, the electric charge on it is. Suppose there is a neutral plate, right? Neutral means equal number of positive and negative charge. When 10 to the power 19 electrons are removed from neutral metal plate, the electric charge on it is. Before transferring, it is neutral, it means equal number of positive and negative charge. But when 10 to the power minus electrons, it will be negative charge, are removed from a neutral plate, then this electric charge on this plate becomes, if 10 to the power minus 19 electrons are removed, how much charge is left on this metal plate? Yes, which option is correct? Yes. Q is what? Q is equal to Ne, right? 10 to the power 19, it means N is here 19. When 10 to the power 19 electrons are removed from a neutral plate, the electric charge on it becomes, N is 10 to the power 19 and E is what? 1.6 into 10 to the power minus 19. Then if solve these two, then Q becomes what? 10 to the 19, 19 minus 19 cancel, 1.6 is left. It means, which option is correct? Yes, B is correct. Plus 1.6 coulomb left on this metal plate after transferring 10 to the 19 electrons from this plate, right? According to this formula, quantization of charge, Q is equal to Ne. N is 10 to the power 19 electron. E is fundamental charge of, that is 1.6 into 10 to the power minus 19. This plus 19 minus 19 cancel, you get 1.6. It means option number C is correct, right? Okay. Next, question number 4. Question is, a body has a charge of minus 2 microcoulomb. It means a body has total charge Q equal to minus 2 microcoulomb is 10 to the power minus 6 coulomb, right? If it has 2.5 into 10 to the power 13 protons, then how many electrons the body has? The body has both protons and electrons. If a body has total this number of protons, then how many electrons this body has? You know quantization of charge, Q equal to what? Plus minus Ne. It means you can write, suppose Ne is total number of electrons and charge of electron is E, plus Np is total number of protons plus charge of electron into charge of electron is E. So Q is given minus 2 into 10 to the power minus 6 coulomb equal to, you have to find number of electrons Ne, and you know charge of electron E is what? 1.6 into 10 to the power minus 19 coulomb, plus number of protons is also given 2.5 into 10 to the power 13, and charge of electron is 1.6 into 10 to the power minus 19 coulomb. So after calculating this one, you get number of electron Ne. So try to solve it. Please pause the video and solve this question. Number of electrons becomes how much? Yes. Yes. Option number, you get answer 3.75 into 10 to the power 13 number of electrons. It means option number C is correct, right? In this way you solve this question. Hope you understood right now. You have to assume that total number of electrons is Ne, number of protons is given, E is common in both cases, 1.6 into 10 minus 19, Q is also given. You just solve it and get answer Ne equal to 3.75 into 10 to the power 13 coulomb, right? After this, next question number 5. Yes, question is, in the process of charging, the mass of the negatively charged body, when you charge the body, in that case the mass of the negatively charged body increases, decreases, remains constant, is not related to the charging process. Which option is correct? You know, during process of charging, electrons transfer from one body to another. Suppose there is body A and there is body B. When you rub these two bodies, electrons transfer from one body to another body. So during the process of charging, the body which gets negative charge becomes negatively charged body, and the body which loses negative charge becomes positively charged body, right? So in the process of charging, the mass of the negatively charged body, when electrons are transformed, you know electron has some mass. What is the mass of electron? 9.1 into 10 to the power minus 31 kg. This much is mass of electron. So when electron is transferred, mass is also transferred now. It means mass increases or decreases of this negatively charged body. More number of electrons and electron has mass, it means mass increases. So which option is correct? Option number A is correct, right? Hope you understood this one. Next, question number 6. Question is, two charges 3 into 10 to the power minus 5 coulomb and 5 into 10 to the power 4 coulomb are placed at a distance 10 centimeter from each other. Suppose there are two charges, Q1 is given, Q2 is given, and these are separated by a distance 10 centimeter, right? Q1 is 3 into 10 to the minus 5 coulomb and Q2 is 5 into 10 to the power 4 coulomb. The value of electrostatic force acting between them. You just apply Coulomb's law, you get force. What is the formula for force? Yes, F equal to K Q1 Q2 by R square. You know what is the value of K in vacuum? K is 9 into 10 to the power 9. Q1 is given 3 into 10 to the power minus 5. Q2 is also given 5 into 10 to the power 4, and R is given 10 centimeter. 10 centimeter means 10 into 10 to the power minus 2 meter whole square, right? And when you solve this one, what you get the answer after solving this one? Yes, try to solve it. Yes. Hope you find the answer. After solving these things, You get answer 13.5 into 10 to the power 11 Newton. It means which option is correct? Yes, option number A is correct. 13.5 into 10 to the power 11 Newton. In this way you solve this question. Hope you understood. Yes, na? Okay. Next question number 7. Question is, okay, I think question is cut it down. No? Okay. It's okay? Yes. Question is, two charges of equal magnitudes and at a distance r exert force on each other. There are two charges right now, Q1 and Q2. These two charges of equal magnitude, both has same magnitude, it means Q, and this one is also Q. At a distance r, distance between these two charges is r, exert a force F on each other. Both exerts force F on each other. This exerts force F on this and this body, right? So what is F? F is K. Q1, Q2 means both has same charge, it means Q square by R square. This is original force. If the charges are halved and distance between them is double, if this charge becomes Q by 2, right? And distance between these two charges becomes doubled, it means twice R. Then what is the net force acting on each charge? Yes. Solve it. F dash equal to K. Charge is now Q by 2. It means Q square by 4 divided by, in place of R, distance is twice R. It means 2R whole square. It means 4R square. When you solve this one, you get how much? K Q square by 16R square. It means K Q square by 16R square. And K Q square by R square is what? F. So F dash becomes how much? Yes, F dash becomes F by 16. Which option is correct? Option number D is correct. F by 16. Hope you understood this one. Yes, now? First you find the original force F equal to K Q square by R square. Now charges are halved and distance is double. You get new force F dash equal to F by 16. So option number D is correct. In this way you solve this question also. Right? Next question number 8. Yes. Question is, each of 2-point charges are double and their distance is halved. Force of interaction becomes n times, where n is. Now, how you solve this question? Yes, try to solve this one. What is the formula for force? K Q1 Q2 by R square. Each of 2-point charges are double. This is original force. Now, both charges are double. It means K twice Q1 and twice Q2, and their distance is half. It means in place of R you write R by 2 whole square. Force of interaction become n times. When you solve this one, you get K 2 to 4 Q1 Q2 by R square by 4. This 4 goes in the denominator, it becomes 16 K Q1 Q2 by R square. This is new force F dash. Right now, new force becomes K Q1 Q2 by R square. So, how much times this force increases? 16 times K Q1 Q2 by R square original force. It means new force is 16 times original force. 16 F dash is. So, the value of n becomes n times means 16 times. So, which option is correct? Yes, option number D is correct. N becomes 16. Hope you understood this question also right now. Next, question number 9. Question is, the minimum value of force acting between 2-point charges placed 1 meter apart from one another. You know force is what? F equal to K Q1 Q2 by R square. R is 1 meter. It means 1 whole square. K Q1 Q2. the minimum value of force. You have to find minimum value of force, and when you get minimum value, you know charge of electron is minimum value, right? Now less than charge of electron is not possible. Charge of electron is the minimum charge, that is fundamental charge. So here for minimum value of force, you get both charge Q1 and Q2 as charge of electron. So you get K E into E by 1 whole square means 1. So K E square. So the minimum value of force acting between 2 point charges placed 1 meter apart from one another is, which option is correct? Yes, option number A is correct, K E square, right? Next, question number 10. Question is, A and B are two identical spherical charged bodies. Suppose there is body A, sphere A, and this one is B. A and B are two spherical, identical means both has same charge. Suppose this A has charge Q and this B has charge Q. Will repel each other with force F. Both are separated by some distance and both exert force F on each other. This A exerts force F on B and B exerts force F on A. And the magnitude of this force F is what? K. Both has charge same, so Q square by R square. Now, a third uncharged sphere of same size is brought in contact with sphere B. A third uncharged sphere C is brought in contact with B. Now what happens? Distribution of charges takes place until both reaches equilibrium position. So B has charge Q. Now when C brought in contact with B, then what happens? Both has equal number of charges Q by 2 and Q by 2. Now B has charge Q by 2, C has charge Q by 2, and then C is removed. It is then kept at midpoint of A and B. Now this is the figure. This one is A, this is B, and third charge C is kept at the midpoint of. If original distance is R, it means distance between A and C is R by 2, B and C is R by 2, and this A has charge Q and both B and C has charge Q by 2, Q by 2. Right? Now, find the magnitude of force on C. You have to find the total magnitude on this C. Now, you have to find force on C due to A, then force on C due to this B. Calculate these two. Then after that, you have to find total force on C. So, how you calculate this one? FCA is what? Force on C due to A. So K, this A has charge Q, C has charge Q by 2. So Q into Q by 2 by distance is what? R by 2 whole square. It becomes K Q square. This is 2 and this is R square by 4 square. So 1 2 cancel. This becomes K Q square by how much? R square by this 2 cancel, this 2 goes in the numerator. Twice K Q square by R square. I think this one right now? No. Distance is half now. So R square by 4 square and this 2 cancel, right? This goes in the denominator. Okay. Now force on C due to B, K, both has charge Q by 2 and distance is again R by 2 whole square. It means K Q square, here is 4 and here is also how much? R square by 4 square. So 4 cancel, this is R square. Now you have to find total force on C. So you know this charge Q has greater, A has greater magnitude, it means force this FCA is greater than FCB. So total force on C is what? FCA minus FCB. It means when you subtract these two, you get what? Twice K Q square by R square minus K Q square by R square. It means you get K Q square by R square. And this one is what? This is original force F. So which option is correct? Yes. Option number C is correct. In this way, you solve this question. Hope you understood this one right now. In the question, it is given that there are two identical spheres and then third charge C is brought in contact with P. So distribution of charge takes place, and then C is kept at the midpoint of A and B. Now to find total force on C, you calculate in this way, right? Hope you understood this question. Next, question number 11. Yes, question is, four charges are arranged at the corners of a square A, B, C, D as shown in the figure. The force on the charge kept at the center O is, what is the net force at the center O? Now you know, at A, positive charge. So at center O, due to this positive charge, force is along this side, and at C, there is also a positive charge. Due to this positive charge, force is along this side, and both forces are equal in magnitude but opposite in direction, cancel each other. So net force along AC is 0. Now due to this plus 2q charge at B, force is along this direction, and due to this minus 2q at D, the force at O is also along this direction. It means both forces add up along this direction. So net force is along this direction. The force on the charge at the center is 0? No. Along AC is 0, but total force at center is not 0. These two charges added up. Along the diagonal BD, along the diagonal AC, perpendicular to side AR. Which option is correct? Yes, along the diagonal BD. Net force is along this BD. So, option number B is correct, right? In this way, you solve this question. Next, question number 12. In this question, it is given that four charged particles are placed at the vertices of a square as shown in the figure. At A, alpha particle, B, beta minus, C, again alpha particle, and D, proton is there, P plus. An electron that is free to move is placed at the exact center of the square. At the center of the square, electron is there, right? In which direction will the electron move? Okay, it means net force on electron at the center is in which direction. So again you have to find total force at the center. So at A, positive alpha particle is there. So due to this alpha particle, the force at the center is in which direction? Yes, in this direction. And due to this alpha particle at C, the force is again in this direction. So both forces are equal and opposite. The force along this diagonal AC is 0. Right now? Now again at B, beta minus is there. So this is negative, this is negative, both are repelling each other. The net force is along this direction. Again at D, positive particle, proton is there. So at the center, electron, so it attracts, and then again the force is along this direction. It means at the center on electron, along AC force is 0, but force is along BD. Net force is this one, this plus this. So particle moves in which direction? This electron. Net force is along this direction, BD na. It means it will move towards A? No. It will move towards B? No. It will move towards C? No. It will move toward D? Yes. The electron net force is acting along this BD direction. So electron is moving towards D. In this way, you solve this question. Option number D is correct. Right? Okay. Next, question number 13. Question is, a proton moving at a constant velocity enters the region between two charged plates. This one is positive plate, this one is negative plate, right? And a proton enters in this charged plate. Which of the paths shown correctly indicates the proton's trajectory after leaving the region between the charged plates? When a proton enters in this region, leaves this region at this point, or at this point, what is the path followed by this proton? You know, positive plate is upward and negative is downward. So field is in this which direction? From positive to negative, downward direction. An electron always moves in a direction opposite to the direction of electric field. It means if it is electron, it moves upward. But this is a proton, positive charge particle. It means it moves downward. So which path this proton follows? A, no. B, no. C, no. It deflects. Which part? Yes, D option is the trajectory followed by this proton is D1. this path proton follows. Right now? Okay. Next question number 14. Question is, for a point charge, the graph between electric field versus distance is given by which one? You know, for a point charge, F is what? Electric field is what? Inversely proportional to 1 by r square. Right now, electric field is inversely proportional to 1 by r square. So, which option is correct? First one, E and R, second one E and R, third one and fourth one. This one is wrong. E is directly proportional to R. No, E is inversely proportional to R, but not R. It is R square. It means this option is also wrong. This option is also wrong. This B option is correct. The path followed by this point charge is hyperbola, this type of path. So, B option is correct. Right? Next, question number 15. Question is, two charges plus 5 microcoulomb and plus 10 microcoulomb are placed 20 centimeter apart. The electric field at the midpoint between the two charges is, you have to find electric field at the midpoint. You know there are two charges, Q1 and this one is Q2. You have to find total electric field at this point. So, you know electric field is vector quantity. So, electric field at this point due to this Q1 charge, you first find. Then electric field at this point due to this Q2 charge, you find. And then which has more magnitude? This suppose due to Q1 charge E1 and due to Q2 charge E2. And you know electric field is what? KQ by R square. So, this one is K Q1 by R square. Here R is at the midpoint, so R by 2 whole square. Again E2 is what? K Q2 by R by 2 whole square. Which one is greater, E1 or E2? Charge Q1 is greater or Q2? Q2 is greater. It means E2 is greater than E1. So, net electric field is what? E equal to E2 minus E1. You just put the value of here Q2 right now and distance is 20 centimeter R and then you subtract these two field. You get answer after calculating. Which option is correct? Pause the video and try to solve it. Yes. Yes, E2 minus E1. First you find E2, then you find E1, then you have to find E2 minus E2. Yes, after calculating, you get option number A. 4.5 into 10 to the power 6 Newton per coulomb towards plus 5 microcoulomb. This option is correct. So, in this way, you solve question number 15 also. Right? Next, question number 16. Question is, what will be the value of electric field at the center of electric dipole? Right? Dipole, you know, a system of equal and opposite charges. Suppose this one is plus Q and this one is minus Q separated by some distance. Now, what will be the value of electric field at the center of this dipole? You know, at the center, due to this positive charge, field is along this direction and due to this negative charge, field is also along this direction. So, both field E1 and E2 are along the same direction and both has magnitude same because charge is same, field is what? E equal to K Q by R square. Distance at the center is also same, right now R, and charge is also same. It means both E1 and E2 is same and both are along same direction. So, total field is what? E1 plus E2, it means twice. So, which option is correct? 0, it's wrong. Equal to the electric field due to charge at center, wrong. Twice the electric field due to one charge at the center, yes, this option is correct. Option number C, half, it is also wrong. Total electric field is twice that due to at the center of the electric charge because both field are in the same direction and both have same magnitude. In this way, you solve this question number 16. Okay, so with this, I am going to end the class, otherwise this video becomes very lengthy. Some questions are left that I will cover in the next part of this MCQ, right? So, keep watching and stay tuned with this channel and wait for the next video. Thank you.